Okay, so the next problem in the lead code we are solving is binary tree level order traversal. Okay, so let's understand what does it mean. So this is a given tree. Okay, so let's say this is a given tree. Like, I mean, we can traverse it in multiple ways, right? Like we have a already we have we know that there are like we can traverse like pre-order, in order, post order, all these things, right? So but that will be like that will be kind of different approach. That's like a DFS. Okay, so now they are asking is a level order traversal. What does it mean? So basically, if you traverse it in this way order, right? This is we'll traverse this first, and then this first, and then this, and finally this one. Okay. If you do this, this is nothing but a level order traversal. Okay. The output would something look like we'll go to 1 and 2 3 4 5 6 7 8 9 10 11 13 14. Okay. This is the this would be the answer for a level order traversal. So what is being asked here is we need to do the level order traversal, but that was just like a printing, right? Like, I mean, that would be whole array, but we also need to ensure that we split the whole list into separate levels. Okay, that is the change here. It's like a modified approach of the DFS. Okay, so in the DFS, like, I mean, the the base approach is we'll just get a values, like, I mean, by traversing, but we'll have to little tweak it here to also split it into the list. Okay, so now let's see how we're going to do it. Okay, so main thing here is let's try to quickly recap like what does this DFS, right? So basically DFS, how does it work is it will make use of a queue data structure to we get to the answer. Okay, so what is the main principle is initially we'll declare this with one root node, we'll keep it inside the node. So we will iterate this queue, like, I mean, we will execute, like, I mean, will what is it, what do you say, like, I mean, will we pass through this queue until this gets empty. Okay, so let's say that if it is there is one element, we'll have to process this, it's like that. Okay, so what is this processing meaning is, so let's say that we have iterated in one, right? So we will pop it, so the base condition is whenever we pop, we need to make sure that we add the its child values 2 1 3. Okay, so the child values will be 2 and 3. Okay, and also as this is popped, it's no more existing. Okay, and similarly again we'll check that queue is empty or not. If the queue is not empty, correct, so what we'll do is, again what we'll do is we'll have to pop this element. Okay, and we'll have to add its childs 4 comma 5, 4 comma 5, right? So this is pop now, right? Which one did we pop? 2. 2 is pop. So similarly we'll be doing the same thing for this one. Let me just last one, this one. Okay, well, if I pop it, so the ultimately it will look like 6 and 7. Okay, and if you just check the pattern, right, whenever we popping, we must be already keep printing the result or storing the result somewhere. So if you check the result, right, it should be looking like 1 comma 2 comma 3, and later we'll also pop this one, right, 4 comma 5 6 7, right? What is happening here is we are basically traversing this tree in a using the depth first algorithm. It's also a level order traversal. We are traversing in this order, right? We are getting the output like this. Okay, but now what is being asked here is we also need to make sure that we are going to split this whole array into multiple correct levels. Actually, 2 3 should be one level. Let me just highlight this. One will be in one level, 2 3 will be one level, 4 5 6 comma 4 5 6 7 should be in one level. Okay, so with the current approach, we can just traverse it. Now let's see that how we are going to break down this into multiple levels. Okay. Okay, so as we just discussed, right? As we discussed, like, I mean, we know that how we are going to pop the element and storing the elements. Okay, but now what is the thing here is we need to also maintain the order. So how we are going to do is, so whenever we were building that list, right? I should have not cleared it. Okay, so let's say that one, like, we have initialized it to one. So whenever we enter, this is the initial. Okay, like now I will check if it is an empty or not. So whenever I check if it is an empty or not, I can check like how many elements are present in the queue. Correct? There is one element in the queue. So it means that that level, okay, that level will going to have only one element. So I will have to pop only one element from the queue. Okay. So and also always like the main principle of the breadth first search, whenever we pop, we need to include 2 comma 3. So as we know, when we started this iteration, there was only one element. We popped it only once. Okay. So the array or like final array would be looking like this one, level one. So next time when we check when we come for the next iteration, queue is not empty, right? We'll be still iterating through it to complete this one, correct? In the breadth first search. So when we come here, what is the length of the array now? What is the length of the array? Length of the array is 2. Okay, the length of array is 2. It means that we'll have to pop the two elements from the queue. So we'll do the same thing, and do the same thing, and we'll build the list 2 comma 3, whatever the element that we popped, right, that we'll build it. And also whenever we pop, we need to make sure that we'll add the 4 5 6 7. Okay, and basically, if you just check the pattern here, right? What is the one key takeaway here is, so how we are going to split the level? It's based on the queue size. So whenever we start the iteration, we'll check the queue size. On the basis of the queue size indicates that how many levels, like I mean, whatever the we are trying to process the next level, like how many elements that are present there, that will be present in the queue. Okay, so 4, 5, 6, 7. So what will happen here is similarly, we'll be just popping these elements and building the list here, and all these list, right, we should be adding to the final result. Okay, okay, let's check the code now. So this will be the okay, this is the level order traversal. Okay, let will be clear now. So as we decided, we'll be adding the root element, whatever the element given root, right, that will be added to the queue. Okay, and now for we'll be iterating through the our queue until it gets empty. Okay, until we process everything and process everything in the queue, we'll be iterating through it. And like I mean, we need to make sure that okay, let's check this first. Okay, so now whenever we entered it, right, so we'll have to calculate the length for it. So that's how we are going to split that whole result into the multiple levels. Like I mean, we don't ideally need this for a normal breadth first search, but it's a modified approach. And as we want to keep a track of the number of elements that is going to be in a level, right, so we'll need this number. Okay, length of queue. Okay, so here what is going to happen is while n, so we can actually use a simple for loop here. That's also be more clear actually. I just went with this one. Okay, so n is equal to length, so we'll be having a temp array to store the number of elements that are present in the tray, right, that particular level actually. Okay, so what we are going to do is, whatever the number of elements that are present in the queue, we'll pop those many elements from the queue, so that it will get, like I mean, all the elements that were present in the current queue. Okay, so whenever we pop it, we always need to make sure to append the left and right nodes of it. If it only if it is not an n, if it is an n, we should not insert it, because like whenever we pop and doing the calculation, right, it will be causing error. So we should not be inserting none values. Okay, so that is there. And result ultimately, like when we build the list, right, until after we pop all the elements present in that particular level, we stored this in a temp result, and we'll adding it to the final result. So ultimately it will look like this one. And also there's a problem called a zigzag, also binary tree zigzag. So what is the change there is, we'll just have to reverse it. Like we'll have to keep a track of the level actually. So let's say that okay, let me show it here. Okay, so we'll have to keep a track of levels. Okay, like let's say that we are initially level 0, and whenever the iteration is done, we'll have to make sure to increment the level. Okay, so here you will check if you're in an even level or hard level. So if you are an even level, we'll just add it directly. If it is a zigzag, we'll have to reverse it and insert it to the final result. That's it.